starting with the same reagent here, BH3, first step. And if you remember here, what I had is alkyne group, an alkyne functionality with two methyl groups. And we call this internal alkyne because the alkyne is inside, and this carbon has a carbon attached to it. Terminal alkyne means you have an alkyne functionality, but you don't have a carbon attached to it, meaning this. This tells you that this carbon has a hydrogen attached to it, not methyl group. So this is an example of a terminal alkyne, just like you can have a terminal double bond. Just like in a terminal double bond, the acidic water gives you the winner of carbonyl winner, and a BH3 with the terminal alkene gives you the antimercarbonyl winner. So here we show that this first one, which is this internal alkyne, ends up giving you ketone, right? So now you're going to look at something like this, which is terminal alkyne. Basically, there's a hydrogen here. It's not shown normally. So normally you just draw like this. So what do we think happens first? BH just simply B and H attacks, so B and H attacks, and we break this bond, we make a bond with boron, and then we make a bond with hydrogen, and we break this one, right? Something like this, some kind of a transition state. Right? So obviously boron and hydrogen are attacking the triple bond of the same face. So what do we get here? Hydrogen, double bond, boron, right?
Yeah.
And then I have to put R and R. I have to do this 3 times. This is good? Basically, we're just doing the same thing we did before. The BH adds onto alkyne. You make one of these. Then you make this 3 times over. Then you oxidize this, meaning with peroxide you insert an oxygen. Then you lose as a leaving group, and then you protonate your leaving group, and you end up something like this. Okay? Is that okay or not? Do we know how we get there? Everybody followed? What's the middle part? This one?
Yeah.
The meat and the potato. This one?
No, the one next to it. What does it say?
This one?
Yeah.
Oh. Okay. So the first one says oxidize with peroxide, and then you have to kick out this leaving group. So you have to lose this leaving group, and then you have to protonate this leaving group.
So it says lose leaving group.
Pardon?
For the middle one, it says lose leaving group.
Okay. So this is the alcohol here, right? Or I mean, I shouldn't call it alcohol. It's not alcohol. I take that back. What is this name?
Enol.
This is enol. Again, OH attached to carbon is attached to double bonded to something.
And then we make ketone.
So what do we do here? Is it stable? Does this collapse? Yes, it collapses. It collapses the same way as the other ones do. Okay, so make a double bond, protonate this with something, and we form something like this. Hydrogen, double bond, right? What is here? An H, right? Hydrogen, exactly. Thank you. This is a hydrogen. I didn't show it there because I didn't show it in the drawing. That hydrogen is really this one, right? Hydrogen A, that's this hydrogen A. This has a special name, okay? The compounds that have a carbonyl group surrounded by 2 carbons are ketones, but the compounds that have a carbonyl group, on one side you have carbon or alkyl group, on the other side you have hydrogen, are called aldehydes. Aldehydes. So you have a carbonyl, and then hydrogen and an alkyl group. It's aldehyde. If you have a carbonyl, you have alkyl and alkyl, then it's a ketone.
So we're still making 3 enols and then 3 aldehydes?
Yes, thank you. Yeah, exactly. Exactly. So the moral of the story is this. Let me just write it here while you guys are taking notes. This is the moral of the story. So the moral of the story is this. You have a terminal alkyne versus internal alkyne. Same reagent, same mechanism, except at the end your enol is a little bit different. So here we form something like this, right? And then here we form something like 1, 2, 3. 1, 2, 3. Okay. Something like this, right? So depending on your starting alkyne, you can make a ketone or you can make an aldehyde. And truth is, with alkene, if the alkene is terminal or internal, you can make alcohol both times. One could be a primary alcohol, and the next one could be a secondary alcohol. So there's a fine difference. But at least with the double bond, if I had a double bond here in the same reagent, I always make an alcohol. I don't make anything else, right? Here, for the double bond, I don't have a choice. The triple bond, it gives you a choice. So what I'm saying is, for your library of reagents, organic chemistry, at the end, that's what you have to know. How do you make a ketone? You can make a ketone by using this reagent if you start with alkyne that's an internal alkyne. You have to know your reagents, how to make a ketone, how to make alcohol, how to make an aldehyde, how to make ether. Ester we didn't study it. Ether for sure you need to know how to make. Epoxide, how to make. What else? That's all I can go.